Some channels like to make comparisons between completely different cars or marquees, but on this channel I like to celebrate the things that actually make them be what they are. And this is one comparison that I've wanted to make ever since I bought Project Beatrix, well, 8 months ago now, or even increasing on that. This is going to be quite an interesting comparison, and one that has never been done before on YouTube. And it is the venerable K-Series versus Ford Sigma, two of the first mainstream all-aluminium production engines. I gather there were a few more before it, like the all-aluminium Rover V8 of back in the day, the first all-aluminium engine mass produced in any certain car, to be honest, even though the Rover P5B and the Rover P6 were very much a niche volume production compared to what we have before very today. And I can't wait, and I have been waiting for a long time to do a comparison on these two engines. I wanted the K-Series to be absolutely up and running and at the top of its peak, and quite frankly I've got this engine to an absolute T, to the same standard as this one, so I could make a fair comparison. Now in this episode I'm going to take a look at actually the comparisons between the two, the history, and how significant these two engines are, and how they actually relate to one another, which in more ways than one they do. So to kickstart things off, we'll talk about the K-Series. Now the K-Series came into production in 1989, originally as the 1.4 in the Rover R8 200 and 400, and this was the displacement that it was actually designed to be. I don't necessarily think that Rover pretty much designed the car to be a 1.6 or 1.8 even later on, but they definitely designed it in mind to be their small engine to replace the aging A series, which quite frankly had done its service since 1952 and quite frankly run its course by then. And the K series needed to be something completely new and fresh, and with a load of government money in order to build this engine, convince the British government that this engine was going to power all the British cars in the Austin Rover group as it was known then. That was very much needed and definitely called for. And then over here with the Sigma started life in 1995 as a collaboration between Ford and Yamaha. And Yamaha don't really have a massive experience with actually car engines, but more or less motorbikes. So it was a very weird collaboration. But for this engine, it seemed to work an absolute treat. And this engine basically replaced what was going to be what was the Ford Valencia engine at the time, which was the old Kent engine, which was kind of, it went through various disguises, and at this stage it would have been the high compression swirl engine. And then obviously you had the CVH engine, which was the slightly bigger engine, sort of 1.4 1.6 sort of capacity. Both engines weren't very brilliant. They were okay engines, and they got it from A to B. And like the A series that this replaced, the Kent engine was very much the A series equivalent on Ford's side, and that engine pretty much had been in production in the Ford Anglia since what, 1959, something potentially like that. So again, that engine had run its course, and the CVH engine had already been in production about 14-15 years, and quite frankly that was not particularly refined and a little bit disappointing. It's not normal and not abnormal to see a CVH blow a load of smoke and oil through its piston rings and out the back of the car before 50,000 miles had come to pass. Now with the K series, the construction is very, very simple, very technical, compared with every other engine from that time that used basically ARP head bolts. Instead, Rover decided to go actually back in time and actually do something that was very much featured on First and Second World War fighter jet planes, with basically a sandwich design of a piston engine, where the actual head bolts go all the way from the top of the cylinder head all the way into the bottom, and all the torsional forces of the engine go through these bolts. So the bolts go from the top of the cylinder head all the way to the bottom oil gallery, and it's basically, it just captures the whole thing in this sandwich construction. And it's something that has actually been copied since then by a few other manufacturers, even though I suspect that the head gasket failure of this design wasn't a particularly great feature. That is not down to a design of the engine, it is purely down to the design of the head gasket itself. Why oh why did Rover opt for the beading? I don't know. But anyway, that was a pretty advanced construction, extremely high engineering and quite risky by Rover. But I think they knew what they were doing. It took several years of design and improvement in order for them to say, yep, this engine is ready for production. And a lot of engines go through this kind of thing. I mean, the Ford Sigma, I think, was being designed on the drawing board from the late 80s. So kind of around the time this was being launched, this was very much in the mind of Ford, who had already previously launched the Ford Zetec engine, the famous Ford Zetec engine, of which this has absolutely no interchangeable parts. Despite the fact that it's called a zetec-se, Ford like to confuse people. It's not a Zetec engine. There is no interchangeable parts between this and the Zetec engine. And basically with the K series you have hydraulic tappets, very much a thing back in the day, 70s, 80s, 90s. A lot of cars had hydraulic tappets, which is why it's so important to change the oil, otherwise they get blocked and then they start making a racket. On the Ford Sigma engine, in comparison, you get solid bucket tappets, a little bit more noisier, a bit more rorty, but nevertheless I think Ford did a really good job with this, because actually side by side on idle you wouldn't actually know the difference. Both these engines are very, very quiet at idle. So I think the Ford Sigma engine for a start was very, very over engineered in that respect, that they could actually make a much more cheaper engine. Hydraulic tappets naturally cost more to manufacture than solid bucket shim tappets, which if they have to be adjusted you need to get the correct level shim. Bit of a pain, but really honestly I've not known any Ford Focus Sigma engines in particular to need this kind of work to be done. Another thing that this engine has that the Ford Sigma carried on really, and it was a first for any car manufactured, and that is the crank bearing ladder design. So instead of having 5 separate bearing caps to support the crank, as on every other car engine of this time and before, and many after, to be honest, the whole crank is supported on one big ladder, and that supports all 5 in this rigid cage, and it stiffens the block. And that for me is a plus point in terms of refinement, and in terms of its capacity to support performance applications on much more higher spec and powerful models. So they definitely developed the K series in mind that they were going to possibly build bigger engines, but also people are going to want to up modify them to a much more higher spec. And obviously the VVC system worked perfectly with that, and it got about 158 brake horsepower to this thing. Unbelievable. And I suspect strongly that Ford looked at this engine and thought, okay, that is a good design. That crank bearing ladder design is really good. Let's do this with the Sigma. Let's put this at the bottom and to give it that strength. The only difference being is that on a K series you can change the crank bearings, but on a Sigma you can't. Ford say that the tolerances are far too narrow and you cannot change any of the bearings. So when you get big end knocking because you've run out of oil, it's a completely new engine. And there are people that will either confirm that or deny it. There's some people that have gone about changing the bearings in these engines. But they also took it a stage further. Just like the K series has a complete camshaft bearing cage, exactly like the crank bearing cage. It's a cage that supports all the individual cam bearings. On the Sigma is very, very similar, slightly different because you can take the individual bearings off, but honestly in a Sigma you don't really need to do that because they never go wrong. But they try to apply the same cam bearing cage to the top of the engine, but in a slightly different form to this, probably slightly more individual. There's a few pieces to it, but you can see the inspiration that this engine gave to Ford, and no other engine had copied the K series like the Sigma. The last thing before I forget is really honestly having all these tolerances really, really fine at the bottom end of the engine and at the top end, tightening everything up. It basically created the situation where long-term wear didn't really happen And quite frankly, I don't know many of these engines that have failed if they've got the correct amount of oil in them. Even if they've got any oil in them, there's no reason why you can't do 250,000 miles on these Sigmas. It really is possible. And on a K series, the same, absolutely the same. It may have gone through a head gasket in that time, but it will still function if it's done properly. Now, with the Sigma, there are a few things to this engine that they added that the K series didn't add. And one notable feature, which was quite exotic for the time, was powder coated piston rods. Now, the only thing that I can understand from why they did that is because they basically reduce the amount of friction, internal friction with the engine, reducing sound and vibration and just increasing the refinement. That's the only thing that I can add to that. But also, this engine was the first Ford engine with a plastic intake manifold. I know that sounds completely sexy when I say that, but really honestly, it's good stuff that to know. And it's potentially one of the first engines to use a plastic intake manifold, although I've got a feeling that some manufacturers had already started before Ford. Even though I think Ford definitely used the K series as an inspiration for the Sigma, the construction is not a head sandwich bolt design. Ford did not do that. They went through the traditional cylinder head ARP bolt style cylinder head to block design. But what they did is they had to make the cylinder walls a little bit thicker to accommodate the fact that it wasn't a K series. It didn't have these longer bolts. But ridiculously, comparing the weight of a 1.6 K series and a 1.6 Sigma, this is about 90 kilograms dry, and that's 99. So it's still lighter. So Ford put a heck of a lot of thought into this engine to get it lighter than an engine that supposedly has this sandwich design to reduce weight, because having the bolts means that the cylinder block can actually be thinner because you don't need that extra strengthening. And there is a very good reason for that on all aluminium engines that I will come to, and why a lot of manufacturers were far behind these two engines, put it that way. From a servicing perspective on both these cars, both of these engines are the interference type, which means if the belt breaks, the timing belt that is, you will have valves and pistons clashing. The valves and pistons occupy the same space but at different times, but obviously if the belt breaks, that is not going to happen. So ironically, it's probably a different engine you're going to have to use, otherwise you're going to be doing a heck of a lot of work to repair the damage. But out of both of these cars, I would definitely say that the K series sounds much more sportier, and this is from a car enthusiast perspective. From somebody who's not interested in cars, I would say the Sigma is slightly more refined, but in terms of how it sounds sportier, is definitely the K series basically win over the Sigma. I don't think the Sigma is a very sporty sounding engine, and I know a lot of people do modified exhaust, especially on these Focuses, and they don't sound great. They don't sound brilliant, but they sound okay. Whereas a K series, well, on a standard exhaust it sounds nice. The advantages of using an all aluminium engine, i.e. an aluminium block, which up to this point was purely cast iron. It was the mandatory thing, and it was the mandatory thing far long after these cars, these engines were manufactured, I should say. And the advantage of aluminium is it is much lighter than cast iron in density. Now the problem with that is cast iron has a much more higher tensile strength. Now that means basically that the blocks would necessarily be much stronger than aluminium. So for the same sort of size block made in aluminium, it certainly wouldn't be as strong as cast iron. So manufacturers basically have this compromise of making the blocks much more thicker, because the aluminium is just not as strong in tensile strength. Now the K series overcame this. That's, I suspect, one major reason why Rover decided on the head bolt design, to keep the block as basically light and thin as possible. Now, some people could argue, because of the head gasket failures, especially on the 1.6, 1.8 versions in particular, that block just wasn't quite as thick as what it should have been, even with the bolts. And the truth is, I think time has shown that the higher tensile bolts you can get these days can actually counteract that and take that that weakness out of the equation. So I think Rover got it spot on, but Ford did not do the bolt construction. But for some reason that they managed to get the block just so strong and so light, it's untrue. I don't think there's anything particularly magical about the way they've actually manufactured the actual block. It could be a very different manufacturing process to Rover's K series, but nevertheless they did something to counteract that weight penalty that you may actually get in an aluminium block. Because the whole idea of having an all-aluminium engine is because it's lighter than a cast iron engine. Therefore, you're reducing the weight at the front. You're not having an impact on MPG or performance, and creating a much better weight distribution. Obviously, cast iron blocks tend to be obviously heavy at the front, so therefore you have more weight on a front-wheel drive car. Front-wheel drive cars definitely benefited from all-ali engines. Aluminium also has a much faster thermal conductivity, so the cooling performance is much better and can help the engine reduce the probability of abnormal combustion, such as pinking and pre-detonation. And the same goes for the compression ratio, which is quite healthy for these two engines, I will say, which is much higher. So aluminium engines can use a much lower grade gasoline than cast iron engines, and that is fantastic for much lower grade markets, particularly like Brazil, where they use something like E85, and both these engines can definitely run on that, and I've checked. And also, being all aluminium, the blocks do not fur up and internally rust and corrode like cast iron blocks. And I'm not saying cast iron blocks are going to corrode to nothing, they don't, but they fur up quite nastily, and you'll see it in the coolant bottle where it will go brown and manky, and that's exactly what is potentially caused by a lack of coolant changes. But cast iron blocks very much tend to internally fur up. You don't get anything like that on all aluminium engines. The coolant is pink in both of my cars, and they will both remain pink because these engines just don't fur up. Another couple of down points to an all aluminium engine, particularly at this stage, and I suspect it would have cost Rover a lot of money to put that into full production from the design stage, and the Sigma, is the cost. Aluminium engines they cost more to make and basically tool up. The manufacturing process is significantly different to cast iron from what I can imagine, so the costs of that would pretty much kill off any benefit in the car world, particularly when we're talking about mass-produced cars with low profit margins. And it's even more, not especially Rover, because these were way more expensive than these brand new, but the fact that Ford decided that their next small engine was going to be an all aluminium engine, that is a very, very bold move on Ford. And it just goes to show that Ford in the 90s would definitely run by the engineers and not the accountants, because I'm pretty sure the accountants would not have enjoyed this engine whatsoever and the costs that it accumulated through production. The last negative really about aluminium engines, especially of this age, is they are not really well suited to high performance applications, which is why the Ford zetec engine and the Rover T series, which is the equivalent of the zetec engine, I might add, those engines both used cast iron blocks. They came out before these two engines, and they are more suited to performance applications, high performance applications. But nowadays, in the last 20-25 years, technology's moved on, and cast iron has now been kicked into touch, and pretty much every engine today is all aluminium, and they can take high performance. And why? Possibly a combination of some of the technology with the cam ladders, and certainly some of the K series technology and design philosophies have definitely gone into a lot more of these modern engines. The only thing that is cast iron that is used in engines relatively so is the actual liners, because during the early stages of aluminium engines, basically the engineers would have probably discovered that the reaction between all aluminium liners and an aluminium piston didn't really help matters. So cast iron liners are still used to this day in all aluminium engines. Failure points, well, most Ford people are going to say, oh, it's the case here, it's going to blow its head gasket, and that's very true. The original head gaskets have this original elastomer polymer sort of beading on them, which naturally soften and break, and then the water and oil start mixing, and then you start losing the water. And because owners just kept on driving them until basically the car overheated, and then that cooked the head, and then obviously it may have been a complete scrap job if the liners have actually sunk. The cylinder liners, once they go below the level of the block, you can shim them, but ideally you need another block. It's too much of a faff, to be honest. So a lot of these cars have actually died because of the K-series head gasket issue. But today that is no such a problem. You know, you still hear failures here and there. You see a lot of K-series on the original head gaskets, so it is proven that they can do high miles on them, but eventually they will need to be replaced, and replaced properly, like I've done with mine. If you get the proper kit, no other issues. And the truth is, that's the only issue with the K-series. They just go on and on and on. There's no issues with them whatsoever. The Sigma, the only issue with these is the owners not checking the level of the oil. It is user error. It's nothing to do with the engine. I think people not changing the timing belts after 10 years and then they snap and that's it. That's the end of the engine. Or running low on oil and then you get the big end knocking sound. I'll tell you something. I've heard so many stories from owners about the K-series, and this engine can definitely run very low on oil and have no bad effects on the crank whatsoever, and you can replace the bearings, whereas on this it's a throwaway engine if that happens. So a really bad point for the Sigma there, but it's down to user error, and I suspect that this is kind of down to user error because owners really just, as a matter of course, just open the bonnet and check the coolant levels. It's not hard. Check the coolant level and check the oil level in this one, and these are not problems. Two reliable engines, and that's it. Now, in terms of power output, I will just go through some rough figures. Now, the Ford Sigma 1.25, I can only compare that to the K-Series 1.1. So these are the smallest variants of the range. Now, the K-Series 1.1 could be 8 valve, could be 16 valves, it could be an 8 valve carburettor, SPI, MPI, there's a number of them, but I'm just going to go with the 16 valve multi-point fuel injection as featured in my 45, and that would give you about 75 horsepower and 95 newton meters of torque, right? And basically the Ford Sigma 1.25, slightly bigger capacity, so let's just give it some credit here, around 70 horsepower, around about ish, so just fractionally less than a K-series, and 110 newton meters. So in terms of power output already, the Sigma doesn't look particularly great, but has much more torque than a K-series. And I'm going to repeat the same thing with the 1.4. The Ford Sigma 1.4 as featured in the Mark IV Fiesta, in the Mark I Focus as the poverty spec engine, 75 horsepower and 124 newton meters of torque. The K-Series 1.4, 103 horsepower and 113 newton meters of torque. That's ridiculous. That's over 25 horsepower more than a Sigma, but less torque, fractionally less torque. That's interesting. So two engines have been set up very differently here. So you can definitely tell that the Sigma was set up for torque, and the K-Series was more or less on output power side of things. And then we have basically the ultimate comparison really. Now, obviously the 1.6 is what I've got in my Focus, but this is a 1.8 K-Series, so I can't quite compare these two. But let's just, for argument's sake, say that this is a 1.6 K-Series. So the Sigma 1.6, 100 brake horsepower. I don't know why I've actually looked at my sheet, because I should know that off by heart. And 145 newton meters of torque. K-Series 1.6, 109 horsepower, so 9 more, but 138 newton meters of torque. So the K-Series, again, wins hands down with a lot more power, but just fractionally less torque. So that's an interesting comparison. Two very different engines, but they drive very, very similarly. And you've seen me drive both cars. I'm not going to do that as part of this episode, but quite frankly, they're very similar engines in the way they pull. But obviously, they go in different cars and different variants. So I think the K series was set up for definitely larger cars like the 45 and the 75 even, whereas the Ford Sigma engine was namely for the Fiesta and Focus. It did find itself in the Mondeo as a 1.6 ti-cvt later on in life, 125 brake horsepower. So they definitely got something more out of the pair of them. But the ultimate versions, I will tell you, is the Sigma 1.7, which was featured, I believe, in the Ford Racing Puma with a variable camshaft timing as well to go with that. Very basic stuff. It was very much a technology in its very gestation. Ford didn't really do twin independent variable camshaft timing until probably 2007, 2008 when the Sigma got it. But basically that engine produces 155 brake horsepower and 162 newton meters of torque. That's some power for what started out as a car with half the amount of horsepower as a 1.25. So a lot of development went into it. And the K series, the ultimate version of the K series, is the 1.8 litre version with the variable valve camshaft timing. And obviously Rover had their own system where the actual camshaft is split essentially into 4 pieces with 2 timing belts. And that got you 158 brake horsepower and 174 newton meters of torque. So in this one, the K series beats both the Sigma in power and horsepower, although I would say slightly unfair to the Sigma being fractionally smaller, but they're very, very similar engines in terms of what they produce. There's not much difference. Now, comparisons. I'm going to pretend, for argument's sake here, that because this is a 1.6, just pretend that this is a 1.6. Yeah, no, it's not. Just pretend, okay? Go along with it, guys. So for argument's sake, this is 100 brake horsepower. This is 109. So K series wins on that one. But in terms of torque, the Sigma is just better. This is 138 and this is 145. So either side, either way. So what do you want? Do you want more torque? Do you want more horsepower? It depends. I'm not someone who is much more into like performance orientated stuff. So someone can probably tell me which would be ideally better. But in truth, it's apples and pears. So really, with the 1.6 K series, now we're going to talk about stroke. Now that is the distance that the piston has to travel up the bore. Now the stroke is 79 millimeters, right? Now the bore on this is 80 millimeters. That is the width, the diameter, I should say, the diameter of the actual cylinder bore itself. Now that makes it a short stroke engine, sometimes known as an undersquare engine. Now if you don't know what a short stroke undersquare engine actually is, and this is as a 1.6, it is only just a short stroke engine, then basically it just describes an engine that is free revving at very, very low RPMs and produces a lot more peak torque at lower RPMs, whereas long stroke, which this engine only just is, which I'll talk about in a second, will basically hold its torque and produce much more higher torque at much more higher RPMs. So you have to rev this a little bit more to gain that top torque bracket. But essentially, that's what it is. There's a lot more pros and cons to short versus long stroke, which is why both of these engines are very close to being a square engine, where the bore and the stroke are exactly the same. The 1.6 K series is only just a short stroke engine. But I will tell you now, the 1.8, which this is very different from the 1.6. It's actually a long stroke engine, where the stroke is a heck of a lot longer. I think 89 millimeters, so way bigger than the bore. The bore remains the same. The stroke was much bigger. So this actually is a long stroke engine, and it produces its peak torque at much higher RPMs. So maybe more suited to the CVT gearbox than actually I thought. and certainly well suited to the VVC system which was fitted to this 45 and many 25s. Now the Sigma, in contrast, has a stroke of 81.4 millimeters and a bore of 79 millimeters. That makes this a long stroke engine by about 2 millimeters, and really honestly, like I've said before, it just means that this car has to rev a little bit more to get its peak horsepower at much more higher RPM. And as I said about compression ratios, aluminium engines allow the cooling system to be much more efficient and to prevent pre-ignition and pre-detonation, which means the compression ratio can be fractionally higher for what you would expect from a petrol engine. The Sigma being a 10.5 to 1 compression ratio, and the K series is an 11 to 1. And as I've said before, the dry weight, I've researched this from several different areas, and I am saying that a K series is 99 kilograms from dry, and that's possibly a 1.6, not a 1.8. This 90 kilograms. What did Ford do to make this so light? It's just so clever. Now, in terms of behaviour and how they drive and how they sound, I can't really talk about these two cars very much because these are the automatic versions, and most people wouldn't have driven an automatic one of these and a CVT one of these. Especially these were like rocking horse poo back in the day, and they're even rarer today. Really honestly, you get a more characterful whine from the Sigma engine with the Mazda automatic gearbox, and the CVT certainly makes the K series sound a bit more raughty and ready to go in quite a nice way, but different to the manual comparison, so I can't really talk about that. Now, in terms of startup, the Ford Sigma engine sounds more like an orchestra. The K series, it's just quiet. Both of these are just equally as refined when looked after. That's the simple truth. The Sigma, despite having solid tappets by design, which is supposedly noisier, it's not actually that much more noisier than the K series at idle, and that's the truth. But out of both of these cars, I would definitely say that the K series sounds much more sportier, and this is from a car enthusiast perspective. From somebody who's not interested in cars, I would say the Sigma is slightly more refined, but in terms of how it sounds sportier, is definitely the K series basically win over the Sigma. But these engines are linked together in quite an interesting way that actually not many people know about unless you actually looked into it, or if you were into Caterhams for a start. But for a start, Lotus, they believed in the K series despite its early flaws and head gasket issues early on. They really loved it. They put it in a lot of their cars. They simply did a lot of work to the block to stiffen it up and make it even more powerful than what it was. So they believed in the K series. But also there was another company called Caterham, and they needed a new engine for their Caterham 7 to replace the aging Ford engine at the time. And I believe the engine was a Ford Crossflow engine, and Caterham did a lot of research on what engines they could put into their cars, and quite frankly the K series in 1991, this was around the time Caterham were looking for a new engine, quite frankly was the new cooking model on the block. It was brand new, way ahead of everyone else. It was exciting new light aluminium technology, and for a light kit car, sports car in the Caterham 7, what an absolute winner. And it did and they absolutely used it for about 15 years until MG Rover collapsed and the K series engine had kind of run out of production, and all the surplus units had been used up to build surplus 25s, 45s and 75s that were kind of hanging around an MGF version, the MG versions as well. Basically Caterham just used it as their own mainstream engine for quite a number of years, those 15 years in fact. And then obviously they had a problem because the K series was gone forever and they needed a replacement engine for it, and they looked in a lot of different places. Can you guess what engine they used to replace this venerable K series? Oh yes, you got it in one. The Sigma engine. How predictable is my channel, or is my video just predictable? That is how these two engines basically link up in all manner of respects, from a manufacturer that very few people have bought from, being a low volume specialist sports car kit car supplier, essentially Caterham. I know Caterham's history is a bit more varied than that, but nevertheless that's the perception that I have about the company. And quite frankly, replacing the K series with something equally as light and compact was not an easy task. And the qualities of the Sigma, being another lightweight free revving engine, was just perfect for the choice, a perfect choice for the replacement for the K series, despite the fact it was 11 years old. But it was upped to about 125 brake horsepower thanks to the twin independent variable camshaft timing basically they added on later on. It's a very technical thing for basically adjusting when the cams open and close the exhaust and inlet valves. It's a very technical thing to understand, but basically Rover did it with the VVC system in somewhat of a sort of more mechanical way, whereas Ford went the electronic way with solenoids on the camshaft sprockets. And that's how it remained with Caterham really until the end of production, until what, 2018, 2017, 2018, when they were kind of phased out, and it was with Caterham ever since then. I'm not sure what engine that Caterham have actually used in replacement of the Sigma, but there are quite a few engines now that are all aluminium and would be right for the job. You know, an EcoBoost engine would be quite a good candidate, and yes, I've spoken badly about that engine, but quite frankly the later ones are not so much of a bother these days. So really, to sum up then, both engines have had an absolutely unbelievably long life, and I'm not surprised because I don't think you can get more reliable and less complicated engines. They're not complicated engines, they're just solid, bulletproof, reliable engines, the pair of them, and there's very little to tell them apart. I mean, the K series continued for 16 years in its original guise until 2005, when obviously MG Rover collapsed, but then became known as the N series because the Chinese tend to do a little bit of tinkering here and there. The N series was a very short-lived engine. It had a multi-layer gasket instead of the old elastomer, and there was a few little tweaks they did, but the N series was pretty much a K series. And then MG decided, well, the owners of MG decided that they would like to strengthen it a little bit more, and basically did some reverse engineering to the K series in order to turn it into the CvT engine, which was released in the MG6 in 2011 and stayed in that car until 2015, when the facelift MG6 came out and they got rid of the old what was the remnants of the old K series in that CvT heart. And pretty much all I can say is that engine was very much a highly strengthened K series. It looks like a K series underneath the fancy rocker cover and all that. It had a turbo and it produced 158 brake horsepower on that engine. So really, on a technicality, this engine survived for 26 years. And then a bit more simply, the Sigma was in production for 22 years, maybe 23 years, pushing to 2018. But by that stage, these engines have basically fizzled out in the bottom spec Ford Focus Studio and Fiesta, I believe the Fiesta Studio, very low spec Fiesta models. But I believe that these engines were still widely available as a 1.25 in 2017 plate Fiestas. I know a few people have got them, and they speak the world of them in comparison to the I mean, it's quite remarkable, isn't it, that these engines have led such a life. But is it surprising? Nah, not surprising at all, because if you've got a great engine that's cheap to run, very reliable, minimal servicing, and they just keep going on and on and on, of course they're going to last a long time. These days engines need replacing every 10 years. Now that isn't necessarily because the engines are just not as reliable, even though I will say that is probably a small factor, but the truth is emissions has killed a lot of these engines. And the K series, if MG Rover hadn't gone bust, the K series would have probably remained in this kind of form for a few more years at least. I don't think MG Rover were thinking about replacing it, or didn't have the funds to replace it. Certainly if BMW had kept Rover, the K series would have probably gone out the window in 2003 to be replaced by a lot of their newer engines at the time. But the Sigma itself, you know, there was no need to replace such a fine engine, and there's nothing really that bettered it. The EcoBoost replacing the Ford Sigma eventually being phased in around 2011, and slowly but surely more people turned away from the Sigma and bought the EcoBoost models. I mean, in hindsight, the K series, the golden years, was the early years between 1989 and sort of 1993, 94, where basically it was just a cooking model. It was new, it was 16 valves, it was all aluminium. There was a lot to talk about it with its new design and just lightweight construction. And there was a lot to be said for this engine. That's why the R8 and the Metro sold quite heavily in huge numbers, and this was at a time where Rover were really on a high from their collaboration with Honda, and it showed. It sold in its drones. And these were the days where Rover was ahead of Ford, way ahead of Ford, and everyone else in many degrees, to be honest. This engine certainly paved the way for greater things. Unfortunately it wasn't to be, but honestly it was way ahead. And then by the time the Ford Sigma came out in 1995, the K series was a little bit less special. 16 valves especially being the order of the day. You know, twin cam 16 valve engines were kind of becoming more common, but still Ford decided to go with an all aluminium engine. They could have just made this as a cast iron block, you know, similar to the Zetec, just a smaller version of the Zetec, but they decided to go for all aluminium in their collaboration with Yamaha. And that's quite interesting, because most manufacturers like VW, they didn't decide to go down the all aluminium route in their mainstream cars for several years after, and quite a few other manufacturers were way behind. I think from a nostalgic perspective for myself, I remember as a child of the 90s, you know, in the late 90s, early noughties, these were everywhere. I think between the mid 90s and mid noughties, I think on every street there must have been a few of these Sigmas, a few of these K series lurking under the bonnets of Fords and Rovers. And it's why I champion these two marquees on my channel, because quite frankly this is the golden generation of cars. Peak motoring, where motoring was at their most reliable, but not being over complex to the point of less reliability because of the amount of electrics and toys added onto cars these days. And it just makes up two of the most important engines of that period of time. And quite frankly, it's a metaphor for the fact that everything really was much better, a heck of a lot better. And these two engines were absolutely at the heart of that peak motoring generation. I mean, how many people have actually had a Rover with a K series or Ford with a Ford Sigma engine? I think more people than what people actually realise. I mean, there is just no winner in this battle. There is no battle. The comparison is comparing two of the greatest engines that was manufactured in the 90s, noughties. And I would like anybody to tell me if there is a better mainstream engine. I'm not talking about high performance car engines. I'm talking about engines that everybody drove on the road, in terms of their sophistication, to their reliability, and what they actually gave to the world of engines in terms of the technology that has been somewhat copied in certain respects, or at least inspiration has been taken from them. In a metaphor, quite frankly, the Sigma is the sun who carried the torch in a much brighter light, and the K series, this is the father that started the light in the first place.